Hello everyone. My name is Ioannis Savvidis, and today I will present you an overview of data marketplaces, which are based on the blockchain technology. Let's start with the data, personal data. According to a report of Business Insider Intelligence called the Internet of Things 2020. By 2027, there will be more than 41 billion IoT devices, which is a huge number if we compare it with the 8 billion IoT devices that existed in 2019. And also, it is expected that the IoT market will grow to over 2.4 trillion annually by 2027. And of course, this huge growth of IoT devices implies a huge growth of the produced data, and it comes with many challenges and barriers. But this data, as you can imagine, has value. And more often than not, this value translates in financial profits. According to Clive Hamby, data is the new oil. Excuse me. But why data has such a value? What can it offer? So personal data actually can bring very important insights to a company after analysis. First, and the most obvious, is the tailor-made advertisements. By collecting data about users' activities and hobbies, for example, a company can send to them targeted advertisements, which are chosen based on users' profile. Also, a company can collect data about its own products. This could be, for example, patterns of use of an application or a product which can be used for optimization reasons. So data in general can be used by a company in order to make sense of its environment, make decisions about the future, and potentially to gain a competitive advantage. This advantage can, and most of the times, lead to increased profits. And in this light, data is a strategic capital of companies as it forms a digital economy. Digital data become digital assets, which represent measurable economic value. So, how data is collected is another good question that probably most of you know the answer. But I will mention it like for completeness and cohesion reasons. So in the traditional model, data is generated by sensors, which more often are located in devices, with direct or indirect access to the internet. This generated information is collected and sent to the servers of the company. And afterwards, the company control and manage this data. Examples of personal data can be gathered. For example, personal data can be gathered by smartphones or by smart devices in the context of smart cities. It can also be wearables and healthcare devices that transmit data about users' activity. Or even our browsing history. So now let's see some challenges that exist in the area. Data can also be collected by data brokers who basically analyze it and sell the produced information to the interested companies, sometimes without the knowledge of the data providers. As a consequence of that, many concerns are raised regarding the privacy and the security of the personal data. And after all, we are all familiar with different famous scandals that happened in the past. One of the main problems that arises because of these concerns is the lack of trust to the ones that manage the data, as there is little to no transparency on how this data is used or from whom. Availability of the data is also a great concern for the entities that that manage it, and also for the users. And lastly, there is a reward, because as we said, the companies are using this data to increase their profits, but the users, the data providers, don't get any share of this. Another problem is related to the data silos. As you can imagine, if there is like a central entity that collects and stores a massive amount of data from users, then it is extremely difficult to share it with other stakeholders, both for practical reasons and for policies and privacy reasons. For example, a company that collects the data maybe doesn't want to share this data with other competitors. And also, it can be understood that it is very costly for users who send their data to a service provider to share it at the same time with other stakeholders, such as researchers or someone else that maybe is interested to this data, or maybe for him or for her, the data are beneficial. Another problem deriving from this is that a user can have her data to multiple different service providers, and thus to lose some value that would have if the data stored together and controlled by only one entity, which in this case would be the user. So a promising solution to these problems is coming with the blockchain technology. But what exactly is the blockchain technology? I assume that some of you already know this answer. But in general, blockchain is a self-governed peer-to-peer network that most of the times include financial capabilities. So blockchain in general consists of four essential elements. This is the hash function, a digital signal to a peer-to-peer network, and a consensus algorithm. As you can see here in this slide, on the left-hand side, you can see that there is a centralized ledger that every transaction is actually logged there. For example, we have Bill that sends $10 to Jenny, and this transaction is written in a centralized ledger. This ledger can be a bank, for example, or a company. But on the right-hand side, every user has her own ledger. So when Bill creates a transaction, he writes this transaction into his own ledger, and then he broadcasts the transaction to the other peers of the network. Then everyone collects all the transactions. So this pattern is actually for every user. So everyone collects the transaction that she received, and then they organize it into blocks. After that, depending on the consensus algorithm that it is chosen in the implementation of the blockchain, they come into a consensus, into an agreement on which transactions are valid and which are not. Here you can see how a block looks like. It consists of two parts, the header and the body. In the header, there are information for the block, such as the block version, the Merkle tree root hash, which is a hash, the root of a tree, which is made by hashes. I will explain it in the next slide. A timestamp, the n bits, which is actually the difficulty of the proof of work consensus algorithm. So proof of work actually, there is a calculation that takes place during the proof of work. And in this calculation, the algorithm tries to compute a hash which is lower than a target hash, so than a threshold, let's say. And this threshold is determined by the n bits, which is the difficulty. And when the proof of work finds the answer to this puzzle, let's say, of calculating, then this answer is the nonce, which is the random value that it is introduced to the algorithm in order to calculate the right hash. And then we have the hash of the previous block in order to form a chain. And then we have the body of the block, which has inside the number of the transaction and the actual transactions. So in the previous slide, yeah, I talked about the Merkle root. So the Merkle tree is a data structure actually that it is based on hash functions. In practice, imagine a binary tree that the leaves of the tree are all the transactions. So what we are doing is we hash all the leaves, which are all transactions, and then in a higher level, we combine every two hashes and we hash them again. In the end, we end up with a single hash, which is the root of the tree. This is important because we can reproduce the Merkle tree by knowing without the need of knowing all the transactions, because an argument to that would be, okay, why we don't just collect all the transactions and hash them all together? Then in order to reproduce the root, we would need to have all the transactions, but now we reduce the number of the needed information. And thus this also is used for validation purposes, and so we don't need all the transactions in order to validate a block. So here we have all the blocks that are connected together, creating the chain. That's why it's called also blockchain. But also we have with the blockchain, especially with Ethereum, we have the smart contracts. Smart contracts are pieces of code that are executed if a condition is fulfilled. On Ethereum, smart contracts run on top of the Ethereum virtual machine. The code of the contract is public, and thus it is transparent, and also it's not updatable. The code is written in Turing complete bytecode language, which is basically it's the EVM bytecode, which is a hexadecimal representation of the contract. The most common language to write smart contracts it is Solidity, which is very similar to JavaScript. EVM has two kind of storage, let's say. Yeah, basically it's the memory and the storage. In the memory, the data is transient, and in the storage, storage is a persistent memory. When a transaction affects the storage, the state of the EVM, then this leads to a cost, which is calculated in gas. So every transaction that we send to the blockchain, it costs some gas, which we have to pay in every transaction that we are doing, if the transaction affects the persistent storage. But how blockchain can help? Why all these are important for a data marketplace? So with the use of the smart contracts, we can impose different conditions under which our data will be used. So firstly, we can decide who will have access to the data and who will not have access to the data. We can decide if we want to share our data based on why it will be used, and also based on the region that the consumer may be. And of course, we can select the time frame in which the data will be available for someone to buy it. However, in reality, this is half the truth, as we cannot be sure what will happen to the data after the consumer buys it. But there are studies that try to solve this problem of reselling the data and the replication of the dataset, and also try to answer questions on how can different procedures can be applied on the data without actually disclosing it. So also blockchain can be used as a trusted third party. Through the use of smart contracts, again, we can determine the policies, the rules, and the prices of the data. At the same time, we are sure that the smart contract enforces the compliance between the two or more parties that participate in a transaction. Because it is public and non-updatable code, transparency is also provided, and everyone can automatically or manually can check the validity of the code and the transactions. And also smart contracts can ensure the integrity of the data. And this is because whatever information is stored on the blockchain cannot be changed. Of course, it is not just that. Blockchain most of the time comes with financial capabilities, as we said before. For example, Ethereum comes with Ether and with countless tokens that can be created and used on top of the platform. This is very practical if we want to build a system which is based on financial transactions, such as a marketplace. So in our case, that we want to build a data marketplace seems perfect. Next, blockchain can be used for registration and authorization in a system like a marketplace. And this is beneficial in terms of privacy, for example, because of two reasons. So the first is that blockchain provides us with pseudonymous identities. So it is more difficult for someone to identify who we are in reality. And secondly, because we do not have to disclose anything else except the address that we have, this is even safer because, for example, in a centralized system like an e-commerce website, we need to provide a lot of details about ourselves, including our credit card information. Another reason is the additional cost and the fees that the third party would require. But okay, someone can argue that fees exist in blockchain as well, which is the gas that we said before. But here I'm talking mostly about arbitrary fees that are imposed by a service provider to increase their profits. And lastly, as we said earlier, it can help for the phenomenon of the data islands, the data silos, as we said. It makes the sharing of the information faster and easier, because data is not stored in a centralized mean, which is isolated by other entities. So, what is a data marketplace then? How can we build one? What are the main components? So, according to Sometal, 2013, data marketplace is a platform on which anybody, or at least a great number of potentially registered clients, can upload and maintain datasets. Access to and use of the data is regulated through varying licensing models. And personally, I think that this is a very good definition. It is very precise and explanatory. And because based on that and on the literature, we can identify some entities that are required in order to describe and to build a data marketplace. So firstly, we have the data providers. These as you can imagine, are the users who provide the data. In some works, they are called data producers, but this is based on the context, because there are cases that one can provide data but not to be the producer of the data. She may be a reseller of it. So we can say that a consumer, for example, bought a data set and then he can resell it, but she's not the provider of she's the provider of the data and not the producer. So we have N providers, where according to the definition can be a large number of registered or non-registered users. Then we have the data consumers. These are the users that buy the data. And then we have the governor, which is in the definition is this part that says that we need something to regulate the marketplace through varying licensing models. And so the government, or if you prefer, the orchestrator of the marketplace is responsible for monitoring the transactions and impose some rules and the agreement between the interested parties, and make sure that the processes and the protocols will be followed. So next, there should be there are the data sets. For each user I, there are L number of data sets. Of course, these data sets need to be equal in terms of that doesn't need to be equal in terms of size. Now, for each data set should be a price. This price can be determined based on different criteria. And also, there is the agreement between the data consumer and one or more data providers. So let's see the basic components of data marketplace. The first one, as mentioned before, is the governor, the governance. The governance can either be centralized or decentralized. By centralized, we mean that the company controls the system, and with decentralized, we mean that a blockchain controls it. The governance is responsible to set the rules and to monitor that everything is going according to the rules. Also, it is the government should find if someone is behaving against the agreement and the contracts, and to enforce penalties. Then we have the user workspace. The user workspace is actually the environment that the user interacts. For the data provider, could be the user interface which will be used to be registered or to upload her data. It can also be the way that she sets her privacy preferences and the way that she determines under which rules the transactions will happen. And lastly, it can include an SDK, for example, in order to connect the user application with the data marketplace in order to send data to it. On the other hand, we have the data consumer. It includes a set of purchasing options, such as search through the data, applying different filtering options, and also the way and the means that regulate the transactions. Then we have the transaction part, which includes the financial system and the transaction protocol. With the financial system, we imply that the mechanism that controls the pricing of the dataset. And by transaction protocol, we mean basically the algorithm that should be followed by the two parties in order to successfully and fairly complete a transaction. And by fairly, I mean four things actually. The first one is that the data provider will be compensated, will be rewarded for the data that she provided. The data set will be of high quality. Also, we need to reassure the data provider that if if they behave according to the rules and share their data with the data consumer, they will receive the full amount of their fee. And also to reassure the data consumers that if they behave according to the rules and pay the amount of money to obtain a data set, they will receive the complete unchanged set of data they requested. Then we have the storage. This is referring to where we can store the data. This is not a simple problem because there are issues such as privacy, security, availability, and trust. A first solution to that is the cloud storage. This can offer actually many advantages as it is the most common mean that exists. But the problem with that is that it is a centralized solution, which is not necessarily trusted. Solutions to that, of course, include to encrypt the data before storing to the cloud. And this is actually used quite a lot. For example, to encrypt the data with a symmetric key using symmetric cryptography, like an algorithm like AES, and we can store the data afterwards in the cloud. This way, the cloud provider cannot see it, so they consider it protected. Another solution could be a decentralized file system like Swarm or IPFS. These are systems that are based on peer-to-peer networks, and particularly Swarm is based on Ethereum blockchain. Another solution is to store the data locally. This has the benefit of both enhanced security and privacy, but it brings a lot of the burden to the user side. There is also the directed acyclic graph, which is utilized by IOTA. At least this is the most well-known implementation. IOTA calls the whole thing a tangle. Of course, directed acyclic graph used in other applications as well, but in this context is mostly used by IOTA. And lastly, there is the blockchain itself. But here there are also many problems in terms of privacy and in storage. In terms of storage, because blockchain is actually offering a high security level, but not privacy. And generally, it's not a good idea to store raw data on it because everybody can see it. And also for the storage aspect, the problem is that it will become very large, very fast. And because the peers of the network has a copy of it, it will be very difficult for some peers to participate in the process. There is also the data integrity. Data integrity has to do with data verification and data validation. And data verification is linked with the completeness of the data set. We mostly check about inconsistencies in what the data provider sells and what the data consumer buys, while data validation is connected more with the data quality. which means if the data is correct and useful. And in this category, we can also include discovery of replications inside the marketplace. Lastly, we have the data analysis. Data analysis may or may not be offered in a data marketplace. It basically depends on the context and the purpose of the marketplace. And also it is an extremely challenging topic, as it is very difficult to ensure privacy of the data during its processing. So this part includes actually all the different ways that data can be processed and produce meaningful insights. And this can be done in centralized or decentralized way. An example of decentralized way can be, for example, gossip learning, in which Ludovico is more expert. Here we can see all the components together. So depending on the architecture and the design of the platform, user workspace and storage can be directly linked. And the most obvious example of that is for the user to have her data stored locally in her device. Also, transaction is connected with data integrity because, as I said earlier, we should ensure that transaction is fair, and that which means that the data consumer gets what she paid for. And all the components, of course, are connected to the governance. So let's see some solutions now. The paper that I chose in this section is again papers that in general they describe a whole architecture and give some solutions in different aspects that corresponds to the categories that I described earlier. But none of the following papers specifically addresses just one problem, so they are a little generic. In this paper, in terms of data quality, in a paper by Zheng et al., there are some suggestions about how we can provide data with high quality, and the author suggests here hardware checking and software way of doing things. So the hardware checking is actually by maintaining a list with trusted vendors, with trusted brands. So basically to say that, okay, these brands are trusted and their products provide accurate data. And based on that, to create a first filter. So each device, except for the data, transmits also its identification details. And if exists in the data, in the list that we maintain, the data is accepted, otherwise it's not. And the other suggestion is based on the software aspect, is based on machine learning techniques. This was a little bit ambiguous in the paper, as they didn't mention something specific about that. Some other ways suggested by Ramachandran et al. In 2018. First, we have the dataset rating, which can be done on smart contracts in order to be immutable, and also a rating mechanism on blockchain would be beneficial because we can prevent situations such as accusations to the third party for unethical promoting of a particular asset. This asset can be a data set or something else. And here, but in the context of the data marketplace, is of course a data set. And here the authors also argue that it is important to check that, and I think they are right, it is important to check that a rating is available to the data consumer only if she indeed interacted with the data provider. And also the authors here suggested another way, which is the token curated registries. So in token curated registries are actually a big topic to discover. So in general, the idea is that we have some curators. These curators maintain a list. So you can think of it like a list of restaurants. Let's say that the curators maintain a list of restaurants, so the best restaurants in the city. And this list is actually linked with some tokens, so it has some value. So let's say that it is connected with 100,000 tokens. So we have the candidates are other restaurants that they want to participate in this list, because this list has the best restaurants in the city, so they want to be part of this list. So what they are doing, they are going and task to buy tokens in order to participate in the list. And what the curators do, they check this application and they vote if they want this restaurant, for example, is good, it can be part of this list. And then we have another entities, the consumers, that are simple users that they can just have access to this list and they can see it. So yeah, this is a very generic and general description what TCRs, token curated registries, are. So instead of restaurants, if we put data sets, then we can maintain a good quality data sets. This is the whole concept. And of course, the better the data sets in the list, the token will gain more value. And this is actually the incentive of the curators to maintain a good list. So in terms of data quality, again, we have another paper by Zheng et al. That is written in 2020, and it's called Blockchain-Based Trading Platform for Big Data. It describes a solution to evaluate data quality based on three aspects, which is the integrity, the consistency, and the accuracy of the data set. So in the described system, a data consumer buys an amount of data, and after getting it, sends a feedback evaluating these three factors. The author suggests that these factors, the SI, the SC, and the SA, should be in arrays from -t to t to avoid spam and dishonest feedback. And then based on this formula that you can see here, basically what we are doing is we sum everything and we conclude in a rating about the quality of the data. And then in terms of rewarding systems, here what the authors are doing is based on this formula that you can see, which includes the quality that they calculated before and the size of the data set, they calculate how much the provider should be rewarded. However, to me, this is not a very good solution, because the quality of the data is based on the feedback that the user gives, and basically because then the rewarding is based on the feedback. then the data consumer has an incentive to give the lowest possible feedback. So yeah, and in terms, and then we have the data transfer. This is actually how the buyer will get access to the data after she bought the data. One solution is proposed by Mazur et al. In 2020, so this year, and it is based on certificate-based proxy encryption. Essentially, the process is the following: a data provider is registered in the system and registers also her devices and her sensors using actually a smart contract. She provides a symmetric key to the IoT devices, which use the key to encrypt the data and transmit it to the cloud provider. Then when a data consumer requests the data, it does it by contacting the data provider. And what happens then is that a new smart contract is generated, which describes this agreement. The data provider updates the smart contract with the re-encryption key. Then the cloud provider re-encrypts the data and stores it to a temporary location from which afterwards the data consumer can obtain it. In the following solution by Zheng et al. From 2020 again, so these are this is the same team that published, the same authors that published the rewarding system. They have another suggestion for that. This is by using agents for storage of the data. Agents is actually another peer-to-peer network that they store the data for a fee in order to be incentivized to do so. And also here, a central entity exists that is called Key Generation Center, which, not surprisingly, generates and distributes the keys to the different users. So when a data provider requests access to the data, the agent requests the re-encryption key from the data provider to perform the re-encryption. According to their evaluation, if I remember correctly, the data re-encryption seems to add a constant time of overhead, so it doesn't matter of the size. It is unrelated to the size of the data set that it is encrypted. And I think that's the last one. So here, as a first step, the data provider encrypts their data. The data providers encrypt their data using AES encryption in combination with the threshold encryption key. Then they migrate their data to the cloud provider and split the encryption key into multiple shares using some secret sharing technique. The shares are distributed among specific nodes on the network that called key keepers. This way, the authors can also ensure the availability of the decryption key, even if the data provider is not active or available. And when a data consumer buys the data, the key keepers provide her with the decryption key. The number of the key keepers that are needed for the decryption is specified actually in the smart contract. And that's all for me. I hope that was interesting for you. If you have any questions, I would be happy to answer.
Thank you. Thank you very much for the presentation.
You're welcome.
Thank you.
So are there any questions, guys?
I have a question. Thank you for the presentation. Actually, it was all new information for me, coming from a completely different domain. You mentioned at some point some criteria for pricing, let's say. Are these also within your interest, like your research interest? And could you elaborate a little bit about that? Or is it something outside your scope?
Yes, of course. Actually, let me go to. You mean in general that I said about different criteria for pricing?
Yes, exactly. Not like about a specific formula, maybe,
Yeah,
but
yeah.
about what could be considered.
Yes, of course. Actually, this is part of my secondment right now in fourth. So I'm just getting into this field. It's a new field for me as well. But in general, there are different ways that you can think of pricing the data. So yeah, one, like maybe the most naive way is to price the data according to their size. So you can say that, okay, 10 megabytes of data will cost this much, and 100 megabytes of data will cost this much. But then there are other ways to do it, like to evaluate somehow the privacy damage that maybe these users could have, and based on that to reward them. Or you can there are some solutions using the supply value from game theory that actually calculate how much each data set was useful for a computation, and then based on this usefulness factor, they can reward the users. So yeah, it's new to me as well. So I'm trying to figure it out, because I guess that there are other other aspects for that, including more from the economic field, and I think it's not purely computer science, but it has more economics into it. So I'm just discovering myself.
Okay, thank you very, very much. And I have one more question. Sorry for taking so much time. You mentioned at some point, maybe you covered it, but maybe I didn't actually get it. You mentioned at some point that there is this possibility of, let's say, you giving your data with an agreement, of course, to a reseller, and then the reseller sort of resells it to some other entity that, like a data consumer. Is there, like, obviously there are a lot of implications here around data protection regulations like GDPR and things like that. Is this something that, let's say, is handled by current research in this specific field, how you can be, let's say, compliant to different data regulations?
So not specifically in GDPR, so there are not many like that they take GDPR as their base and they're trying to be so they don't compare their solutions on that. Generally, yes, there are solutions that they try to prevent data leakages. So, for example, one and the project that we are working right now with Ludovico and Thomas, it's based on that. How can we process the data without actually a data consumer has to have access to the raw data, direct access to it. I'm not aware if there are specific solutions that they are evaluated against GDPR, if this is what you're asking precisely. At least I think I found only one, which was not something like super important.
Okay, thanks. I just wanted to see if there's research towards that direction, or I mean, you're also working, as I understand, towards this direction, which is pretty interesting. Thank you.
You're welcome.
So any other question, guys? So if not, then I would like to thank Ioannis for his very, very interesting presentation.
Thank you very much, guys, for listening.